Hello and welcome. In this video, we are going to discuss how to set a bit of a number. Setting the bit of a number means setting that bit to 1. Let's discuss this with an example. Suppose we have number 13 and we want to set its kth bit. That means we want to change the kth bit of a number to 1. The kth bit can be 0. If it is 0, we'll change it to 1. If it is 1, we want to keep that as it is. So that is the meaning of setting the kth bit of a number. Now let's discuss it with example. If the number is 13, this is the binary representation of the number, and we want to set fourth bit of this number to 1. I have shown the fourth bit in red color. Keep in mind we are counting the number of bits from 0. The leftmost bit of the number is 0th bit. So the red bit is the fourth bit. If you count from 0 from the right hand side, that is from the least significant bit. If we change or set this red colored bit to 1, this will be the output that is shown here. So it will change to 0001101. So this number is equivalent to 29 in decimal. So if you input 13, you will get 29 as an output. Another example is if the number is 22, then the binary representation of the number will be this as shown on the slide. And if we want to set the second bit of the number, again I have shown it in red color. It is already 1. Because it is already 1, that means the output will remain the same. So the output will be the same, that is the number 22. So this should be the output. Now how we can do it programmatically, let's discuss that. So if the number is 13 and you want to set the fourth bit of the number to 1, what you have to do, you have to OR this number 13 with 2 raised to power k. So because the value of k is 4 as we assumed earlier, so 2 raised to power 4 is 16. So you have to AND 13 with the number 16. So we will perform bitwise AND operation over here. So if you perform the bitwise OR operation, and in that case if you OR 13 with 16, you will get this result 29. So I have shown the output bit that is set to 1 in red color as well. So this number is equivalent to 19 in decimal. Let's consider another example. If the number is 22 and we want to set the second bit of the number, in that case you will OR this number with 2 raised to power 2, that is 4. I have shown the binary representation of 4 on the slide as well. So if you OR 22 with 4, you will get this result, and as you can see the number will remain the same. So you will get 22 as output. The third example is if again the number is 22 and we want to set its fifth bit, then you have to OR this number with 2 raised to power 5, that is you have to OR it with 32. So this is the number 32. So you will OR it with the actual number 22, you will get this output. So the result is 54. So this is our output. So the next slide, in this we are going to discuss how we can program it. So this is the C code. In this program we have used 3 integer variables a, b and k. In a we'll read the number whose bit you want to set, the kth bit. Then the variable k is used to read from the input the value of the k, the number of the bit that you want to set. In the next step we are finding the 2 raised to power k using the power function. So you have to pass it two parameter. First is the base, that is 2, and the second is the exponent. So power function will give us 2 raised to power k. So if the value of k is 4, so you will get 16 as the output of this power function, PO function. We are assigning that number to the variable b. So the next two line printf statements will print before setting the bit 4th to 1. We are assuming over here the value of k is 4. The value of a is, let's say, 13. So you will get 13 over here. Now if you want to set that bit, you have to perform a or b operation. So here the piping symbol is basically for bitwise OR operation. It's a bitwise OR operator. So this will OR the bits of A and B, and the result that you will get will be copied back to the variable A. As we discussed in the previous slide, ORing 13 with 16, it will give you 29. So the modified value of A will be 29. So the next two printf statements will print the output after setting the bit 4th to 1. The value of A is 29. So I have shown the result on the next slide. So from the slide it is clear that we are inputting two values from the keyboard. One is for the value of A, that is 13. Other number 4 is for the value of K, that is 4. And before setting the bit, the value of A is 13. So we are getting this output. And after setting the 4th bit to 1, we are getting the result 29. I hope you get it right. If you have any doubt, you can leave your doubts in the comment section. I will help you out to understand that. Thank you. Have a nice day.